All right, 1069. First, decide if the triangles below are similar. Then, if they are similar, use the information in each diagram to solve for x. All right, so let's go ahead and take a look at this first pair here. So remember when we're dealing with triangles, these two, one is not mapped directly onto the other. So we're going to have to use the scale factor here to determine whether they're similar or not. So let's go ahead and let's mark the smaller one original, and let's mark this one dilated. We always want to do dilated over original. So if we look at our sides, we do have a couple corresponding sides here. So we have this side, this 9 and this 6. So we're going to do 9 over 6, which you can put into your calculator, and it's going to give you 1.5 or 1.5. All right, so from the 9 to the 6, that's a scale factor, or I'm sorry. From the original, it's the dilated. It is enlarged by 1.5. Now let's take a look at another corresponding side here. So we do have this 6 and this 4 as well. So the 6 and the 4, we're going to do dilated over original again, so 6 over 4. And 6 over 4 can be simplified. Again, we can simplify it, or we can, even if you put into your calculator 6 divided by 4, it's going to give you 1.5. So it does look like we are going by the same scale factor here. So we have one more side. We have x and we have 7. So now we can set up a proportion to solve for x. So we have, again, we'll do dilated over original. So we're going to do x over 7. And we can set it equal to either 9 over 6 or 6 over 4. So let's go ahead and set it equal to 6 over 4. Now that we have our proportion set up, we can go ahead and start cross multiplying. Now you can use any strategy you prefer. You can use a giant 1, you can use fraction busters. I just prefer the cross multiplication because I think it's the easiest. So if we have x times 4, that's going to give us a 4x. And then a 7 times 6 gives us 42. So we have 4x equals 42. To get x by itself, we'll divide by 4. Same with 42. So 42 divided by 4 is going to give us 10.5. So x equals 10.5. Now we can check this if we want. I have to fix that decimal point. It's driving me nuts. It's a little bit better. So x is 10.5. Now, if we want to check ourselves here, what we can do is we can do 10.5, okay, because that's our dilated over our original to check it. So 10.5 over 7. Hey, that also gives us 1.5. So we do have a proportional enlargement here. So we would say, yes, for A, the triangles are similar. And then we could say they have a scale factor of 1.5. All right, so that's all for A. Let's go ahead and take a look at B now. Actually, one more thing we should add to our explanation for A. They have a scale factor of 1.5. Let's add which makes the lengths proportional. So we definitely want to make sure we have that proportional word in, because that's a huge part of making sure that something is similar. Okay, and then once you have that down, let's go ahead and go on to B. All right, so you can see with B here, it tells us to be careful. All right, well, let's have a look here. So we have, if you look here, you can see that they have the smaller triangle, which is mapped directly onto the larger triangle. Sorry for the wonky lines. All right, so you can see now with this information, we have, trying to trace over an angle here, and I'm having a hard time doing it. So you can see I traced over that angle. All right, now if I move this angle, if I try to slide it down to one below it, you can see that it matches up. So we have a corresponding angle set here. So from the original to the larger angle, it's the same corresponding angles. So we know that whatever that measurement is, the angles are going to be the same. Now, let's take a look at this set over here. So this set, you can see that they give us this symbol in the corner of the triangle. So it's this symbol that you see there. Now that tells us that those angles do have the same measure as well. That's just what that symbol means. It means, hey, we've got congruent angles. And finally, we don't need to go on, because according to the angle-angle theorem, that would mean that our top angle would have to be the same. So you can see that that larger triangle, it maps directly onto the, the smaller one, oh my goodness, the smaller one maps directly onto the larger triangle, which means that they both share that top angle. So all angles are the same measurements. So we could say that first. So we'll say the triangles are similar according to the angle-angle, or you could just put AA theorem. All right, so they are similar. Now we need to solve for x. So again, we can set up another proportion for this. Let's go ahead and take a look at some sides here. So you can see in the larger triangle, my length here is going to be it's going to be 16 total, because this, oops, let me switch back to my pen. This part is 12, this part is 4. So the entire length of that side for the larger is going to be 16. So we're going to do 16 over, we want to do it, put it over the length of that corresponding side of the smaller, which is going to be this, which is 12. So it's going to be 16 over 12, and we'll set that equal to, let's find our other set of corresponding sides here. So it's going to be equal to, oops, we want to do the larger side over the smaller side again. So it's going to be equal to x over 7. All right, so now we have our proportion set up. We can go ahead and cross multiply. Again, you can use any strategy you want to work through this proportion. I just prefer the cross multiplication. I think it's what's easiest. All right, so 12 times x gives us 12x. Then we'll go ahead and set it equal to, it's going to be 16 times 7, which gives us 112. And then we want to divide by 12 on each side. And when we do that, we get x equals, it's going to be 9.3 repeating. All right, and that is all for 1069.